Now we are going to see antibiotics, that is beta-lactam antibiotics. Of course, madam meeku introduction part cheppesaru. Now I am going to tell beta-lactam antibiotics, what are that, and penicillins, cephalosporins I am going to tell. Okay, once you see beta-lactam antibiotics, here beta-lactam is the nucleus in this type of antibiotics. What is lactam? It is a cyclic amide. Nothing but lactone ring which is having amide group. Lactone ring means 4-membered ring which is having a ketone group, right? So that ketone group and amide group combinedly we are calling it as a lactone ring. Okay, see what happens here. By the elimination of water molecule from amine group and carboxylic acid group, we are going to get this lactam. So this is lactam ring. By transfer of this hydrogen atom here and double bond will be transferred here, this is called, this we can call it as lactin. Okay, so this is the structure of the beta lactam ring. So here amine group is there and keto group is there, right? This is the beta lactam ring. It is nothing but a 4-membered cyclic amide or lactam, 4-membered cyclic amide group. So see, so here see, if a ketone group is not there, 3 carbon atoms and amide group, we are calling it as azitidine, azacyclobutane, or we can also call it as trimethylene imine or 1,3-propylene imine. Okay, 1,3-propylene imine. So to this we are going to add a ketone group. So we can call it as azitidine 2-one at the second position. This is 1, this is 2. Second position ketone group is there. So 2-one azitidine 2-one. Otherwise we can also call it as 2-azitidinone. Okay, with respect of this ketone carboxylic group, nitrogen atom is attached to the beta carbon atom. Okay, so it is called as beta-lactam ring. Okay, this is a carbonyl compound, carbonyl group. This we are calling it as alpha carbon, and to that it is attached to beta carbon atom. To this beta carbon atom, this nitrogen is attached, so we are calling it as beta-lactam. Okay, next, now we are going to see what is penicillin. It is a group of antibiotics produced by a mold. Okay, that is Penicillium notatum or Penicillium chrysogenum. See, try to remember Penicillium notatum, Penicillium chrysogenum. Coming to the chemistry of that, this is the structure of a penicillin. So beta-lactam ring is there. So beta-lactam ring is there, and thiazolidine ring is there, and having a side chain which is acyl amino chain. So see, or CONH, acyl amino chain is there without these substituents. Okay, so numbering, chemical abstract system, according to the chemical abstract system, numbering will be like this: 1, 2, 3, and second carbon atom will be having 2 methyl groups, and the third carbon atom is having carboxylic acid group. Okay, 1, 2, 3, 4, 5, 6, and 7. This is chemical abstract system nomenclature, numbering. And coming to the United States pharmacopoeia system, numbering starts from nitrogen atom: 1, 2, 3, 4, 5, 6, and 7. Okay. Now we are going to see biosynthetic precursors of penicillin. Penicillin, we are going to have a slit here and here. This is one of the amino acid and this is one of the amino acid. See here, NH, C double bond O, OH, SH. See this part. This is cysteine and this is valine. Methyl groups here, COOH and NH2. This is valine and RCO. This is one of the part. This depending upon fermentation media, this will be changed. Based on the fermentation media, it will be changed. If we use corn steep for fermentation, corn steep liquor, it will give phenyl acetic acid. This is that. Next, we are going to get benzyl penicillin. Okay, this will be based on the fermentation media. If we use corn steep liquor, we are going to get benzyl penicillin. Okay, this is about biosynthesis of penicillins. Now we are going to see the nomenclature. Nomenclature, basic nucleus is nothing but the P-num. Okay, this is the basic nucleus. No any other substitutions will be there like this. Okay, this is just two-membered ring which is having heteroatoms, double bond over one ketone ring, one thioazo groups. So beta-lactam ring and thiazolidine ring. This is the basic nucleus of a penicillin. We are going to call it as a P-num. Okay, Phenum, that is one thia, first position one thia, 4 azo bicyclo, two cycles are there, 3 2 0. Here three membered ring, 1 2 3. Here 2 is there and here nothing is there. So 3 2 0 heptane. So 7 membered ring. So heptane 7 on a ketone is there at this position. This is Phenum. Okay. So see here, penicillin structure. This is RCONH and 2 methyl groups and COOH group. This is the penicillin. Numbering starts from here 1, 2, 3, 4, 5, 6, 7. Okay, penicillin. 6 acyl amino, 2, 2 dimethyl. Remaining part we are calling it as Phenum, right? Phenum, 3 carboxylic acid. That is the IUPAC name according to Phenum. Okay. So here this is penicillinic acid. So see here. So no substitution at the 6th position and methyl groups are there and carboxylic group is there. This is called as penicillinic acid. The active nucleus of the penicillin is this active nucleus. So this substitutions is there and the 6th position amine group is there. That is nothing but the active nucleus of penicillin, 6 amino penicillinic acid. To this penicillinic acid at the 6th position amine group is given, that is penicillinic acid. So now see the penicillin. This is the structure of penicillin. 6 acyl amino, 2 dimethyl, 7 oxo bicyclic, 320 heptane, 3 carboxylic acid. This is the IUPAC name for this penicillin. Coming to the classification. Classification is based on nature. Based on nature. These are natural penicillins, biosynthetic penicillins. Examples are benzyl penicillin. We can also call it as penicillin G, 2 pentyl penicillin, penicillin F, 3 pentyl penicillin. We are calling it as, and some more penicillins, phenyl methyl penicillin, penicillin V, 0 allergy methyl penicillin, 0 allergy penicillins, penicillin O, N pentyl penicillin, N heptyl penicillin, penicillin K, P hydroxy benzyl penicillin, we are calling it as penicillin X. Second one is semi-synthetic penicillins. This is of two types. Penicillinase resistant penicillin, penicillinase sensitive penicillin. These are resistant penicillins. We are also calling it as anti-staphylococcal penicillins. These are two types, oral and parenteral. Coming to the oral, oxacillin, cloxacillin, dicloxacillin, penicillin, nafcillin. And coming to this penicillin sensitive penicillins, these are also oral and parenteral. Ampicillin, amoxicillin. This coming to the parenteral, carbenicillin, ticarcillin, piperacillin. Piperacillin, we can also call it as piperacillin. Okay, next coming to the penicillins with beta-lactamase inhibitors. Penicillins with beta-lactamase inhibitors. We are giving a combination and amoxicillin with clavulanic acid. This is the major drug we are going to use for kids. We are going to have the syrups like in combination clavulanic acid. Ticarcillin with clavulanic acid. This clavulanic acid is nothing but beta-lactamase inhibitors. Next, penicillin combination. So procaine penicillin, benzathine penicillin. So next, based on the spectrum of activity, we are going to have another classification. Effective against gram-positive, benzyl penicillin, ampicillin, oxacillin. This is effective against gram-negative bacteria, timoxicillin. Broad spectrum penicillins, ampicillin, amoxicillin, carbenicillin, becampicillin. Acid resistant penicillins, benzathine penicillins, phenoxymethyl penicillins, phenoxyethyl penicillins, phenoxypropyl penicillins, narrow spectrum penicillins, penicillin G, penicillin V, floxacillin, cloxacillin, mesalanium. Mesallinum. Okay, next, extended spectrum. These are also called extended spectrum penicillins, also called as anti-pseudomonas penicillins. They are ampicillin, amoxicillin, pivampicillin. These are having amine. Next, carbonicillin, carfacillin, ticarcillin. This is having carboxylic group. Next, piperacillin, azlocillin, meslocillin. This is having uride penicillins. These are also called as uride penicillins. This is having uride moiety.